Hello folks, we come to this miscellaneous exercise part 5 video. Here again they ask us to find out the value of a matrix. Certain things are given to us, we have to use the values and find out. There is a matrix X which multiplied by this matrix is giving you this matrix. So to find this matrix X, now first of all we should know what is the order of that matrix, right? So how to find that out? Now this matrix is of order 2 cross 3. This is also of order 2 cross 3. So what should be this matrix in order to get the same matrix? It's very clear to us that it should be cross 2 here. In order to get it as 2 cross 3, obviously it has to be 2 cross 2. So your matrix X is a 2 cross 2 matrix. That's clear to us by looking at the orders. So now let's consider that matrix and let's see how to show that. Let X be any 2 cross 2. That's your wish. Therefore, you will have X, Y, Z, W when multiplied by 1, 2, 3, 4, 5, 6, giving you minus 7, minus 8, minus 9, 2, 4, 6. Let's check this out. It is first row, first column, X plus 4Y, 2X plus 5Y, 3X plus 6Y. Z plus 4W, 2Z plus 5W, 3Z plus 6W becoming minus 7, minus 8, minus 9 and 2, 4, 6. So, here we'll have X plus 4Y to be equal to minus 7 and 2X plus 5Y to be equal to minus 8. We'll modify it. We have to find the value of X and Y. Let's modify this. Multiply by 2. 2x plus 8y equal to minus 40. Solving. Okay. Subtracting or adding or whatever. This will come to minus 3y equal to 6 or y equal to minus 2. Now if y is minus 2, substituting it in this equation will give you x minus 8 equal to minus 7. That is x will become minus 7 plus 8, 1. So got x and y. Look over here also. Z plus 4W equal to 2. 2Z plus 5W equal to 4. So let's have this multiplied by 2. 2Z plus 8W equal to 4. Subtracting, adding, solving, whatever. Minus 3W equal to 0. That makes W as 0. Substituting in there you get Z plus 0 equal to 2 or Z equal to 2. So you've got all the entries, isn't it? So get the matrix also. Let's write the matrix. Therefore, the matrix X is first the X entry, which is 1. Then the Y entry, which is minus 2. Then the Z entry, which is 2. And then the W entry, which is 0. That's it. They've asked us what is the matrix and let us know. Now we quickly come to the next question where they tell us that AB equal to BA. If that is the case, you have to show that AB raised to N is BA raised to N, and later on you have to also show that AB raised to N is A raised to N into B raised to N. Obviously these two things we are going to show by induction. So let's start right away. Let for the first part, let Bn denote the given statement. First step, as we did before, to prove that P of 1 is true. What does that mean? It asks us to show that AB raised to 1 is BA raised to 1. Consider the LHS, which is AB raised to 1, which is AB. And AB we know it's given to us that it is BA. So there's no harm if we call it as BA raised to 1, which is RHS. So I got LHS equal to RHS. So therefore P of 1 is true. Right. Then we go to step 2. Assume P of K is true. What does that mean? That means that AB raised to K is equal to what have I written? 1 meter. raised to NA. To show that bk plus 1 is 2. So you have to show this, right? So first let's consider this. Consider a into b raised to k plus 1. That is a into b raised to k into b. So this much we know already. See, we know that it is bk into a. So this ab, but we also, it's given to us that is ba. So bk into ba. So this can be clubbed together. It can become bk plus 1 dot a. So that makes bk plus 1 true. Therefore, by PMI, AB raised to n equal to B raised to NA is true. Right. Then quickly we do the second part. There also we do the same thing. We denote the given statement. Right. Step 1. To show that P of 1 is true, which means that AB raised to 1 is A raised to 1 into B raised to 1. Consider AB raised to 1. What is AB? So that's, if you want, you can call it as A raised to 1 into B raised to 1. Raised to 1 means it doesn't change the matrix at all. So therefore P of 1 is true. Right. Now step 2. Assume P of k is 2. So what does it mean? It means that AB raised to k is A raised to k into B raised to k. To show that P of k plus 1 is true. So what do we have to show? We have to show that AB raised to k plus 1 is A raised to k plus 1 into B raised to k plus 1. For that, let's consider this. AB raised to k plus 1. We use our indices and we'll split this. Raised to k like this. Okay, what's the advantage? This we know from here, that this is A raised to k, B raised to k. And this is given to us that AB is equal to B. So what happens? This can club together. It can become B raised to k plus 1. AB we call it as B raised to k plus 1. A. Now, yes. Reflected, that's right. Okay. What did we do? AB raised to k plus 1, we called it as AB raised to k into AB. And AB raised to k we knew that we can call it as A raised to k, B raised to k. And okay, AB we flipped it and we called it as BA. And yeah. Yes, what did it tell here? That we can change powers. Here it is told. Right. So if it is like this, it can become like this. That is being told from part 1. So we can have this as, it has been told that AB raised to n is equal to, so you can change powers. So getting it like this. This is from part 1. Now, this can become A raised to k plus 1 into B raised to k plus 1. And That is exactly what we have to show. Pk plus 1 is true. So, by principle of mathematical induction, whatever it is, ab raised to n is a raised to n into b raised to n. That's all about this video. With the remaining problems to come in the next one.